So today's video is we're going to look at a triangle and find out, is it a right triangle? The lesson objective for this lesson is that by the end of the lesson, I can use the Pythagorean Theorem to determine if a triangle is a right triangle or not. Let's go over some vocabulary. Some of these things you've heard before, some of them you haven't. A right triangle. A right triangle is a triangle with one 90-degree angle. And you all have seen this. It has the little box. Okay? That's what a right triangle looks like. There are pieces of the right triangle that you need to know. Okay? The longest side is called the hypotenuse. Okay? So this is the hypotenuse. And when we're talking about the Pythagorean theorem, we're going to call it side C. All right? It's the longest side, and it is opposite the right angle. See how it's across from the right angle? That tells you it's the hypotenuse. So the other sides of the triangle are called the legs. They are the sides on the triangle that join at the right angle. So this side is a leg, and we're going to call it A. And this side is a leg, and we're going to call it B. We're going to use that for the Pythagorean theorem, A, B, and C. One more thing we need to talk about is square and square root. We've talked about it before, but it was a long time ago, so we need to go back and talk about it again. Square is when you take a number and multiply it by itself. Sorry, it's hard to write on the iPad. The square root of the number is that number that is multiplied by itself, okay? So it's the number that is squared. So for instance, the square root of 25 is 5. That's the number that you multiply by itself to get to 25. So what are we going to use to decide whether a triangle is a right triangle or not? Well, we're going to use what's called the Pythagorean theorem. And you're going to use this a lot, and you're going to see it on the map test a lot. And this is one of those things that you can actually use in real life. If you're going to work construction or anything like that, you're going to use the Pythagorean theorem. It helps you square up corners or make right angles, okay? The Pythagorean theorem was developed by Pythagoras, who was a scientist, mathematician. And it's a relationship that happens between the legs and the hypotenuse of a right triangle. And what it says is, if you square the legs and add them together, the length of the legs, you should end up with the square root of the hypotenuse. Here's how that works. So this is a leg, and we're going to call it A. And this is a leg, and we're going to call it B. And this is the hypotenuse, and we're going to call it C. So let's plug this into the Pythagorean theorem and see if it works. A squared, we're going to look at that. So that's 3 squared plus 4 squared. And if this is a right triangle, when we finish, we should end up with 5 squared. So let's solve it and see. We're going to call this C squared because we're trying to find the hypotenuse and see if it's a right triangle. So 3 squared is 9, 4 squared is 16, and we still have C squared. 9 plus 16 is 25 equals C squared. And now remember, we want to find the square root. So the square root of C squared and the square root of 25. So C equals 5. So the hypotenuse, the length of the hypotenuse should be 5. Is it? It is. So this is a right triangle. That's how we're going to determine, is it a right triangle? We're going to look at the legs, we're going to add them together, and we're going to see if their square root is equal to the hypotenuse. Let's try another one. Okay, so when I look at this, I have to determine where I think the right angle is going to be. And I believe that the right triangle will be there. So this is a leg, and we'll call it A. This is a leg, and we'll call it B. And this is the hypotenuse, and we'll call it C. We're going to plug in A and B. So 5 squared plus 12 squared equals C squared. We're not plugging in the 13 because we're going to see if this is a right triangle or not. So 5 squared is 25, 12 squared is 144, and we're going to leave the C squared. Now we're going to add these together, and we get 169 equals C squared. Now, we have to use the square root, so we're going to do the square root of C squared and the square root of 169. So that is C equals 13. Do these match? Yes, they do. So yes, this is a right triangle. Has one right angle. Okay, here's another one. I'm going to show you where I think the right angle is, where it's going to be, and we're going to test it to see if it is a right triangle. I want you to plug in the legs and see if when you solve it, you come up with the hypotenuse. Try this by yourself and then come back and see how you did. All right, let's see how you did. We have a leg and a leg, so we're going to do 8 squared plus 6 squared equals C squared. 8 squared is 64, 6 squared is 36, equals, oh, Mrs. Hall, right correctly. C squared. 64 plus 36 is 100, equals C squared. Now we have to finish with the square root. Square root of both of these makes this C equals 10. 10 and the hypotenuse length is 10. So since they match, the answer is yes. This is a right triangle. Okay, now I just have a series of numbers, an A, a B, and a C. The A and B are legs, and we're going to plug it in and see, could these three measurements make a right triangle? Let's try it, okay? So A is 2.1. So 2.1 squared plus 7.2 squared equals C squared. Okay, 2.1 squared, I did on my calculator, which is 4.41, and then 7.2 squared is 51.84 equals C squared. When I add those together, I get 56 and 25 hundredths equals C squared. I'm going to find the square root, and I get C equals 7 5/10. I'm checking to see if these two match. Well, C up in my measurements is 6.9, is 6 9/10, and C when I solved is 7 5/10. Since these do not match, this is not a right triangle. So no, it is not a right triangle. This probably seems a little bit confusing, but as we use it, you'll get more familiar with it and understand it. We're going to use the Pythagorean Theorem also if we have an A or a B and find the C. We'll do that in our next video. We're going to find the legs and the hypotenuse using the formula. But for this video, we're just trying to determine, is it a right triangle or not?